Yeah, apologies to those of you who specifically came for the talk on flues and chimneys, but unfortunately the guy who was doing that let us down at the last minute. This particular presentation I did in 2006. Apologies to anyone who came then and remembers it. I have actually added lots and lots of photographs in there since, so it's really upgraded since then. It was kind of prompted by this. This was the first slide in 2006, and this is a particularly bad job of subsidence, so it's kind of half prompted it. Although, prior to that, I'd looked at lots of conservatories with various problems. That, as an example, is not a conservatory. It's got a translucent roof, which is fine, but it doesn't have any sides, so it wouldn't count. This one is trying to become a conservatory. I quite like this, actually. But probably doesn't officially count as a conservatory. Yeah, that is a conservatory. This is a very flimsy one. There's some quite peculiar problems with this, which I will be coming to later. This is a slightly better, sorry, that one there is a fairly sort of cheap conservatory. It's fully glazed from top to bottom. There's not a lot to it. This one is slightly better because you've got the little brick walls up to a low sill level, which is probably the more common solution to conservatories. This is a bit of a homemade job, but it's not a conservatory anyway because it doesn't have a translucent roof. This is a very nice conservatory. It's got all the sort of nice features with the sort of faceted bit going round on the curve there, the fancy bits on the roof and everything. Okay. This is not a conservatory because it's 4 floors up on top of a block of flats, and the definition in planning and building regs is a conservatory is at ground level, so it doesn't specifically count as a conservatory. These are the issues I was going to go through today. Planning consent, do you need it or not? Building regulations, do they apply? Foundations, the problems which you get with those typically. Typical problems with superstructure. Cavity trays, it's really cavity trays and sort of flashings where they abut the main buildings. I've got some good examples of problems occurring there, and a little bit on heat loss and what people do with the doors between the house and the conservatory, generally speaking. So planning consent. Do you need planning consent for a conservatory? The answer to that is a kind of a yes, but no, but maybe. Yes, because it's development, but then no, because most conservatories fall into the permitted development rights. But then maybe because there's quite a few exemptions to the permitted development rights. Permitted development rights, which basically took you out of the planning situation. I've not been too specific on all the requirements of that now to comply with it because it was changed in 2013 and there's been a temporary relaxation until 2019. But fundamentally, if the extension, conservatory extension or whatever, is up to a certain volume, which is I think usually about 15% of the volume of the house, that would be the size of the house when it was built, or if it's older than 1948, the size it was in 1948. You can sort of go up to that volume without permission. Sorry?
It's been taken out now, isn't it? It's now just a distance from the rear.
I'm not too sure on that because, as I say, it changed a lot and it keeps changing, yes.
It's a specific
where
you can only have a percentage before. The percentage is gone. You can say 3 metres from the back of a semi-detached terrace.
Right.
Half the width of the existing house to the side.
Okay.
And you can't the dead bit.
But is there a maximum volume still?
Is it in the green belt though? In the green belt?
In green belt.
Yeah, they're do it by volume.
Yeah. As I say, it's so complicated now, and there are so many different things. But you can find all this information on the website, the government planning website. Other major things are that it doesn't. You can't extend beyond the front wall of the property, or 20 metres from the highway. Can't be higher than the house. Not higher than 4 metres if you're close to the boundary, and not more than 50% of the garden. As I say, they're all constantly changing. Can't really understand why they brought in this temporary relaxation for the 6-year period. I don't know whether it's to stimulate the construction industry or what the object was. But I do know some people are building absolutely horrendous size extensions and getting away with it. But permitted development rights may have been withdrawn. If it's a listed building, conservation area, area of outstanding natural beauty and national parks, Suffolk Broads, Norfolk Broads, or World Heritage Sites, then you still need to apply for planning in most of these areas. When I did this in 2006, World Heritage Sites weren't on the list. I was just sort of updating it and checking a few things, and I came across World Heritage Sites, and where are World Heritage Sites in this country? I wasn't even aware there were any, to be quite honest. But there is an interesting list, actually. And sorry? The City of Bath is one, but what do you know what's top of the list? Blaenavon Industrial Landscape. Yes, it's got a whole mixture of good and bad, I guess. Yes. There may be some other restrictions or problems in terms of putting up a conservatory. There may be some restrictive covenants on the deeds of the property which you need to consider. If you're a leaseholder, you'll need to get permission, usually in the form of a licence from the freeholder. That seems to be generally easy in most cases, but if you sometimes get major problems and they get solicitors involved and surveyors or engineers checking designs and all sorts of things for that.
There is another thing, Mike.
Yeah.
I just thought of actually, I come across a few years ago, underground aviation fuel pipelines.
How do you know if you've got one of those? Yes.
The ship oiling from Milton Haven and then
Yes.
it goes all the way up to Heathrow underground.
You're pretty unfortunate if you had one of those underneath your back garden, though, wouldn't you? Yeah, you'd never find out probably for that one.
I've come across it.
Yeah. I do recall many years ago we were doing a new office building in central London, and it wasn't until the stage that they put in for planning and building regs that they got something, well, if it was a building reg stage, they got something back from building regs saying, oh no, you can't put in those piled foundations because there's a tunnel underneath. It was one of these secret GPO tunnels which everyone knows about. But odd things crop up any time. There might be some right to light issues, but I think that's probably most unlikely with a conservatory. Party wall act might apply. Certainly, yes. That's more likely to be sort of highlighted and be aware of with building over sewers. That's getting more kind of tricky now, but I know Thames Water, for instance, they've almost got a little manual on if you want to build over a sewer and standard prices for what they charge for just giving you permission, basically, and checking it all. They probably make some good money out of that. So that is the sort of planning and other restrictions issues. We then come to the building regulations, and again it's a yes but no but maybe situation with those. It's a building work, so yes, you should need it, but no, because there's a Schedule 2 in the building regulations which exempts certain small things like conservatories and porches, etc. But maybe because there are some, again, exemptions to the exemptions which bring it back into the building regs. Sorry. This is the exemption into the building regulations. It's fairly straightforward in what it says. Extension of a building by the addition at ground level of a conservatory, blah, 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 right? But in the case of a conservatory, which is wholly or partly glazed, well, it's got to be glazed anyway, because to be a conservatory, it has to satisfy the requirements of Part N of Schedule 1. Part N has got 4 sections actually, although only the first one actually applies to domestic situations. Glazing, which you're likely to come into contact with, has to be such that if you break it, it'll fall into little, shatter into little pieces so it won't injure you. or it's got to be such that if you bang into it, it won't break, so bulletproof or something, or that it's shielded or protected so you can't sort of break into it and cause damage. So N1 applies to conservatories. The other three, well, N2 is basically saying that glazing which is there and you're likely to come into contact with has got to be made such that you can see it, but that doesn't apply to private dwellings. N3 and N4. N3 is for the windows and skylights. They've got to be such that you can open them and close them safely, so you don't have to sort of stand on a chair and reach right up or something like that. A safety issue, I guess. And the similar thing for is N4 is for access for cleaning, etc. But again, those two don't apply according to that part of the build to the exemption. So, but there is something else later which actually, in a way, brings that back. You've got to sort of consider that requirement, which I'll come to in a minute. That's a further thing from the building regulations on what a conservatory is. The definition: single-storey ground floor, floor area doesn't exceed 30 square metres, 75% of the roof and 50% of the walls are translucent. The glazing, which satisfies Part N, which you just talked about. It should be separated from the dwelling by existing doors or windows, and this is the one which people typically, I won't say ignore, they typically contravene after all the work has been completed. Had situations where people have sort of questioned it, where doors have been removed. People perhaps selling a house, and they have to admit that yes, we've got to put these doors back when we sell the house and things like that to make it legal. It does get picked up sometimes by mortgage valuers. And the last one is energy conservation, basically saying the conservatory should be unheated, but if there is fixed heating in there, then it should have its separate controls. That one is probably going to be upgraded, I would think, in the future, because we're talking about energy conservation this morning, and we're continually making it more rigorous, the regulations. This is some more exemptions to the exemptions, as it were, which basically building reg application will be required for a conservatory in the following situations. If it's in a low position where it'll obstruct the access to an escape window in the property, fire escape window that is. If it's going to obstruct the access arrangements for the fire brigade, if it's likely to affect disabled access facilities, or if it's going to affect the airflow for a balanced flow. I suspect that those things are not considered particularly well when they whoever's designing or specifying the conservatory and locating it is taken into consideration. I mean, does anyone here know which of their windows is allocated as an escape window from the property? I mean, how do you know which windows upstairs you're supposed to escape from if there's a fire? How do you know which doors are allocated for the fire brigade to enter the property in the event? It's a difficult one, that is. CDM regulations, of course, they apply now in all cases. Designers must consider how the conservatory is to be used and maintained, and also any effect on the existing building maintenance. The first one, how is the conservatory to be maintained? It really, if I go back to N3 and N4, which are sort of using, opening the windows and keeping it clean, which have been exempted from the building from dwellings and the building regs. It really means under the CDM regulations you've got to take those things into account, I would say. I doubt very much whether they are taken into account in most cases. And the other thing is the effect on the existing building maintenance. And I suppose also, again, the fire escape from the existing building, which goes back to the first 2 points on that list, really. They should all be taken into consideration. Right, coming back to this one, this property is in Epsom. It was a new property when I looked at it. People had just moved in, they'd had the conservatory put on as soon as they moved in. When the first summer came, the conservatory started to subside, and I weren't getting any joy with satisfactory answers from the conservatory people, so they called me out to do a report. What had happened was, you see there, we've got, oops, is that in there? Yeah, we got just a little fairly tapering crack there where the wall joins against the main building. It's not a huge amount of cracking, but it's sufficient generally for sort of householders to get alarmed. Further up the window frame there's no gapping. It hasn't, in this case, hasn't been severe enough to pull the window frame away. Internally, you see the plaster has been pulled away here as the movements occurred, and along the floor we've got this quite wide gap that's pulling away as well. Why did it happen? Tree, exactly. Yeah, I mean, Epsom, it's an area of heavy clay. I mean, I know it's generally highly shrinkable clay. You've got this oak tree, which is 5 metres away from it. I could just look at that picture and say, well, that could, you know, unless it's got very deep foundations, you're going to have problems with it. It was so obvious. The foundations, some investigations were done, the foundations were only about 1/2 metre deep as well. Even if the building regulations don't apply to it, you've still got to consider, well, what do we need to do in terms of adequate foundations? And to be quite honest, the best way to provide adequate foundations is to follow what the building regulations would have required if they had applied. This is what the building regs say on foundations. They should be constructed so that ground movement caused by swelling, shrinkage or freezing of the soil basically won't affect the stability of the building, which is fairly general. In the approved document for Part A, it goes into a little bit more detail about strip foundations. If you're on rock, your minimum depth of 0.45 of a metre to avoid frost, freezing of the upper soils affecting the foundations. It does say it may need to be increased deeper depending on the locality if you commonly get freezing deeper than that, which I would have thought is pretty unlikely unless you're in the north of Scotland. And the other one is if you're on clay soils, you need to go down to a depth where seasonal moisture content and shrinkage in the soil doesn't occur. It recommends a minimum of 0.75, but may need to be increased to get it on satisfactory ground. It also says you need to consider the influence of vegetation on the ground. I say, how do you deal with the foundation depths in clay soils, which is the most common problems? That's how you know you've got clay there, because you get boots like that. The NHBC standards is the easiest way of working out your foundation depths. I'll just go through what's required there. You need to collect soil samples. They need to go to a laboratory to determine the plasticity index, which then gives us a indication of how shrinkable the soil is. You need to see what trees you've got on the site, what type of trees they are, how far they are away. You need the geographical location in the country. And then you feed this information into various equations and tables to get the foundation depths, which could be 3 metres or deeper in worst cases. With the soils, look at the geology maps, and that's local knowledge should tell you if you've got clay soils there, and you need to consider that. If you have got clay soils and there is concerns about the sort of high shrinkage or that with the clay. You need to basically get some soil samples by using either a hand or power auger. You really need to go down to depths of 4 to 5 metres if you can, and take samples at perhaps half-metre intervals. The soil samples go to the laboratory then for tests to determine what's called the Atterberg limits. There's 2 of these. There's the plastic limit, which is where it changes from the soil changes, the moisture content when the soil changes from a non-plastic to a plastic state. That is, you can mould it in your hand. And then there's a liquid limit when it becomes so mouldable that it's effectively runny, becomes a liquid. From that you can calculate the plasticity index. The plastic limit is determined like this, very simple test. You take a lump of soil, you roll it out into a thread, 3 millimetre diameter. If it forms a long thread, it's got the moisture content is too high, it's in a plastic state, and you keep messing around with the soil. It dries out as you're doing this, and eventually it'll dry out to a state when you try and roll it out into a thread like that, it breaks up into little pieces. At that point you weigh it, dry it in the oven, weigh it again, work out the moisture content. Liquid limit's a little bit weirder in the way you work that one out. You've got this machine here. It's got a brass bowl in which you put a soil sample at a relatively high moisture content. You use a special tool which cuts a groove through the top of it, and then you turn this handle here at a rate of 120 revolutions a minute. The bowl goes up and down and drops onto this hard rubber block. It drops 10 millimetres, and with that sort of vibration it makes the gap basically sort of close up as the soil moves together. And you do it for how many? Yes. What you're looking for is a moisture content at which 25 drops of the bowl closes up the gap over about ½ an inch length. So you have to do it at several different moisture contents and then draw a graph to extrapolate the results from it. So it's quite a few sort of soil samples to take and dry out in the oven and work out water contents of that. That's probably the old method of doing it now, because there's another one which uses a drop cone. Not too familiar myself with actually how this one works, but basically by dropping that cone in and measuring how far, etc., they can work out. I think you do that again on several different moisture contents and draw a graph to extrapolate and get the results for that one. So going back to that, the plasticity index is the water content at which it is becoming a liquid, less the water content at which it's becoming so dry that it's not plastic. And typically a plasticity index will be from just 1 or 2% right up to 50, 60% it can be. If it's less than 10% plasticity index, then it's considered to be non-shrinkable. If it's 10 to 20, it is of medium shrinkage, low shrinkage potential. 20 to 40 is medium, and over 40% is high shrinkage potential. And from that, there are there's 3 tables or graphs in the NHBC standards which we use, but we need some further information on the trees that are present, because all the different types of trees, they grow to different sizes, they all have different ability to suck the moisture out of the ground. So the information on, you need to know the type of tree it is, whether it's broadleafed or coniferous, whether it's high, moderate or low water demand, what the mature height is, and how far it is away from the foundations. And we've got the table here in the NHBC standards which gives that information there. So if we go back to the case of the conservatory I was showing you there, that was an oak tree. Oak trees are here. They're in the broadleaf trees. They're of high water demand, and you've got English, Holm, Red or Turkey oak. Don't know which it was, to be quite honest, but let's say it's English oak, which has got a mature height of 20 metres. So broad-leaved, high water demand, 20 metre mature height. You pick out the graph for the high volume change or high shrinkage potential soil. D over H, that's the distance of the tree over divided by mature height, which was 5 metres over 20 metres, which is 0.25. Go down the 0.25 metre line down there until you intersect the right line there. Two lots of lines. The solid line are for the broadleaf trees, the dotted lines are for the coniferous trees, and then the red colour is for high shrinkage potential, blue for moderate and black for low. So in our case we would be coming down sort of down here 0.25 until we hit this curve here, so we're way below the graph. The NHBC say that if the foundations are going to be more than 2.5 metres deep, they have to be designed by an engineer. In the first instance, I would kind of extrapolate those lines down. So for that conservatory, we would be looking at foundations slightly over 3 metres in depth. But you just have to sort of think about that. Is that sensible? There is one other factor as well. Depending on where you are in the country, you can actually reduce that depth very slightly. As you get further away from the southeast corner, the climate is generally is more wetter, so it doesn't make it, as you can see from the figures, it doesn't make a huge amount. You've got to get right to the north of Scotland before you can take 0.5 metre off the depth of the foundations. So coming back to that one, if you can imagine digging strip foundations 3 metres deep underneath there, it's a bit sort of out of proportion to the whole thing. It's probably a case where mini piles or some other form of alternative foundation arrangement would be preferable.
So you could kill the roots and the trees because you're so close by the time you...
Yes, I mean this is actually another issue which you'd probably get now, because I've noticed more recently we're getting arboricultural reports when people require planning permission, which they wouldn't have required for this. And so typically you get an arboricultural report and they're going to say, oh, you can't dig any strip foundations there because you'll cut through the roots of the trees, and all sorts of restrictions on what they can and can't do.
Sorry, if it's a conservatory, which typically don't want to spend a lot of money on, otherwise it does extension,
Yeah.
is a thin raft with maybe a flexible...
Yeah, but a raft is shallow. This is one of the misconceptions as well. People think, oh, put it on a raft. I mean, we're not talking about here about bearing pressures or the weight of it. It's the fact that the soil is just shrinking away.
Yeah.
So a shallow raft will still go.
I was going to add the flexible joints where so you're allowing it to move, and you're...
That would be the only solution, is to actually accept that it's going to move, and you're going to get some gaps between that and the main building, and cater for it with flexible joints and things, really. But people don't like that. If they move, they get, you know, even the slightest movement, as I was saying, it makes a lot of difference.
With the raft, the NHBC, you have to take the hardcore down to half the depth.
You do,
You've got to dig down 1.5 metres of hardcore, and the tree man won't let you do it because you're cutting through the tree roots.
Exactly, yes.
You can't mini pile because Thames Water don't like mini piles next door to their drains.
Yeah. And it's not necessarily, it doesn't have to be clays and trees to cause these sort of problems with that. I mean, that's just a small porch. I was typically asked to do a report on this. I think people were trying to sell the house and the valuer had picked up that. I mean, all we've got here is slight cracking, or it's even gapping, because it's not really a crack because they were never really joined or bonded together properly. In this case it's not too bad because the window frame is fixed, that hasn't moved, but it's enough to alarm people, cause problem because cause a hiccup with the sale of the property. Doesn't have to be the whole of the conservatory foundations which go. This was quite an unusual one. We've got this solid wall on the side there. I think the builder must have thought it's a solid wall, we better put a decent foundation in, probably went down to a reasonable depth for that. Along the front, he probably thought it's not much load on that wall, so we'll put in a shallower foundations. And we've got some very strange cracking in this point where it seems that this front wall has dropped and broken its back there, and some very strange cracking in this area. That's underneath the front central door where it's broken its back and pulling apart. This is that far corner. I think what we've got here is at the top there is the main wall at the side, which is on a deep foundation, hasn't moved, whereas the foundation to the front wall has dropped, causing that bed joint there to open up. The reason it's zigzagged here is probably because the windowsill is drilled and fixed into that first course of brickwork, and also fixed to the side wall as well, so that's all stayed in its original position. Quite an odd one that one was. If you see what I'm saying there, the cracking along there where that's all dropped, and then it's broken its back there. This one, no brickwork at all on this one, very lightweight, don't need much of a foundation for that one. If you go around the far side of it, obviously something's happened. We've got all this expanding foam in here to fill the gap temporarily. Didn't require much of a trial pit to find out what was happening with the foundations. We just stuck up a slab, and you can see basically you've got about 2 inches of concrete and the thing's built on that. This one here looks a little bit better built, but it still had some problems. The whole thing tipped away again from the original house. In this case we've got the gapping down here, and the window frame is also pulling away because the movement. So depends really how well the frame is fixed back to the main house. Sometimes they'll stay in place, sometimes they'll pull out very easily. And that was on the side wall of that conservatory. Because of the way it was going, the distortion, you see the two door have become misaligned. This one had a lot of trees, and it was on a shrinkable clay. The whole thing again had rotated and tilted away. This picture was taken from inside. You'll have to trust me that when you stood inside and looked at that, you could actually see how it sloped down. It never really sort of comes out so well on the photograph. It was also pulling away considerably from the main wall of the house on the side there. This was a more localised problem. Note the slabs here seem to be sloping down a lot, which suggests the ground is a little bit not too good on the surface at least. There was a problem just localised in this area. Behind that flower pot there, you see the bed joint of the DPC brickwork had dropped below there. The rest of the place was okay. Everything else has stayed in position. So with foundations, it's really important, if you don't want to have any problems or movement, get the correct depth in the first place, which really needs people who are building or supervising it know what they're doing and got the right information. When you have got problems of movement, you really need professional advice, because my experience, most of the jobs I've been called to look at, when problems have occurred, the clients have first of all gone back to the builders and conservatory people, and they've come up with all sorts of weird solutions, not really tackling the problem as it should, because really the only real solution is to underpin it or replace to the correct depth, or even knock it down and put new foundations in. Sometimes that's cheaper. Superstructure of the conservatory generally doesn't cause too many problems. Building regulations say it should be constructed to transmit the load safely and carry it out without too much distortion, etc., which is about what you'd expect. This comes back to this very flimsy one here. There's a big problem with this one. The people have said it was sort of very flexible, they're getting a lot of movement in the walls and everything. The Conservatory people came back and they actually strengthened it by adding, it was these pieces here, and they've actually added an extra piece of extruded aluminium section which they've screwed to the main verticals, covered them with plastic. That seemed to have cured the problem of the walls bowing in, generally speaking, but what they failed to do was to do any strengthening along this line here, and it was still able to sort of flex in and out at the top, because the only thing which was holding that top part in place would have been the roof, but the glazing is only just basically sitting on the rafters. It's not actually physically fixed to it as a solid roof would be. So what happened was that area there bowed out and the glazing got pulled and dropped off the first rafter. It was in sagging in that position, obviously leaking, but in severe danger of falling down at any time. The other issue with this one was that where the glazing is supported off the rafters, it was about 10-15 millimetres higher than where it was supported along the eaves there. So there's a slight sort of bow this way on the glazing, and underneath that cover strip there, just you can go up it and in, you've got sort of gaps at each side. Right, this one is the conservatories there is sort of fixed in between the two house walls. It's quite a large one, got quite a huge roof structure. The owner complained that he was getting all sorts of, it seemed to be quite a lot of movement on some of the parts, and he had a lot of leaks on the property. One thing that had happened was that these glazing panels, some of them had actually slipped down the roof. They were not actually, they were just basically laid on the rafters, not fixed in any manner at all. They slipped down by 25 millimetres and were letting water in places. It wasn't really a conservatory because, as you can see, it's open straight through to the house, so that should have complied with building regulations, but I don't think an application was ever put in on that one. The roof structure was quite big. It was, on the whole, it seemed okay. You've got these sort of bars, tie bars across the eaves and everything, which acted like trusses. These members here, the hips, they look substantial size sections, but where they come up to the ridge, there seem to be sort of big gaps there. And you have a similar situation also where they come down to the eaves. I couldn't see any significant connection of the hips either at the top or the bottom. I think they're probably just stuck in there and being actually held up by the rafters, which wasn't really a very satisfactory way of dealing with it. Let's go back. That was the tie bar across at the eaves, which seemed to be well fixed to the rafter there. Wasn't a problem with that. That's took the end cap off one of the rafter sections. See how it's made with a couple of one section goes in, glazing goes on, and then the other one goes on the top of it. You can see here a screw. That was put in afterwards, so that the screw head just catches the bottom of the glazing to stop it slipping down. And they hadn't put those in everywhere, so although we'd had problems with one or two panels dropping down, eventually all the others which hadn't been fixed in position would have gone down. In fact, I'm not even sure that was a satisfactory way of dealing with the problem anyway. Right, this brings us on then to cavity trays, and it really should be cavity trays and sort of flashings where you join to the main building. That one looks like quite a good example, quite neat sort of lead flashing there. There probably isn't a cavity tray in that position because there's no evidence of any weep holes. That's a situation where you don't need a cavity tray. That is an interesting way of dealing with bringing in a pitched roof of a conservatory against the pitched roof of a house. They've actually sort of extended the house roof out and brickwork, etc. to build it. Again, doesn't need a cavity tray. This is a solid wall, as you can see. The roof is just coming up here. There was obviously some lead flashing in there originally, which wasn't very satisfactory because we've got just this stick-on type flashing put on afterwards. I'm not sure of the reasons for that one actually. This one here, in this position there, we've got, it's built against the wall and we've got a valley gutter going through there. Comes back to how do you keep that clean and maintain it? Very difficult. I mean, you'd have to have a kind of special long pole with a scraper on the end, but then you couldn't actually get in position to use that because of all the bushes, etc. by there. So it probably never got cleaned out, the gutter didn't, and this ultimately led to some problems. As you can see, a bit of vegetation growing up there at the top corner. Quite a bit of vegetation actually, it's probably been there a long time. That was obviously blocking the gutter, causing damp, and on the face of the wall you've got fairly sort of faint hairline cracking there, but I'm sure that's caused by damp coming through the wall. The cracking, if you can see it, I think probably some of it there follows the joints in the blockwork behind it. It's undoubtedly caused by the damp, I think. This is in Gloucestershire, which is a little bit far from my normal patch, but these people, I think they read the paper from the 2006 presentation, which is on the internet somewhere. I get about 1 or 2 calls a year as a result of this paper. But they wanted me to come out and have a look at this because they had some major problems and concerns with the conservatory. Looks quite fine from there. Where it butts up to the back wall of the house, it was dry lined, and they had a few damp problems. It would appear to be getting in, obviously, at this level, getting behind the dry lining. It's coming down and hitting the top of these where it's coming out, dripping down the sides of the windows and the doors, all the way down to the floor. In fact, there's so much of it, it's pouring out the bottom here. You can see these little bits where the, the plaster dabs are holding it on. There's a big damp bit there. I'm not quite sure why that's so big there. I never saw it in that condition because when I came they'd stripped all the plasterboard off, and someone else had been there and actually done a report. But at this stage, you see, we've got some lead flashings going up there, which all looks good. They concluded since the water was getting in there, it must be because we didn't put a cavity tray in. The builder said no, we didn't allow in the cost for cavity trays, and I think the building owner actually ended up paying another builder or someone to actually install cavity trays. They made a complete mess of it. You see the condition of the brickwork up there, it's all spotted. Down this corner here we've got a funny detail, so they slapped on this lump of lead there. Complete mess. You can see the bit of the pointing there. They've put in weep holes on every level, whereas these proprietary cavity trays are supposed to sort of cascade down inside, so you should only need one weep hole at the bottom. Yeah, that's the condition of the pointing as well. They also siliconed the face of the wall because it was a fairly exposed location, getting a lot of driving rain against it. In fact, if water was getting into that wall now, it's probably through all the weep holes they put in there. There are so many of them. But the problems with the water coming in still continued, just as bad as it was before. Somebody else had been out there from the Conservatory people to look at it and done a very detailed report. He'd had bricks taken out so he could inspect the cavity trays which he'd put in, concluded that the cavity trays had not been laid properly, they'd cut bits off them. There were all sorts of issues there with the cavity trays. The lead flashing wasn't the right code, it was code 3 and it should be code 4 or something, and that. Did a very big report on all that. But that wasn't really the problem at all. As I say, it's unlikely that any water was actually getting into the face of that wall, so the cavity trays were really a waste of time, weren't doing anything. This is obviously the other slope, and you can see there's the cover strip coming down here and the flashing going behind it. You can see a little detail there. Take the cover strip off, you can see we've got a little channel section there. What was happening, I think, was the rain was hitting the face of the wall. It's basically then coming down the little channel there, and I've got a section which I took from the report, which when I copied it from my reports I came out as a negative image for some weird reason. But yeah, as you can see, the rain hits the wall there, runs down the face of the lead flashing, behind the cover strip into the section, which is incapable of carrying all the water down the slope. It floods over that. Sort of around here and ultimately down the back of the dry lining there. So that was the cause of that damp. What they really should have done is something like this. This is not the best solution, but you have got a reasonable channel there for water to run down if it hits the face. Really the lead flashing should come over that first cover strip and that and cover it well. That's another situation where you've got slight gapping there where the frame hits the wall.
There's going to be more issues now because of the rainfall we're getting. So we're getting such intense rainfall. Whereas I went on a conservation course recently and said all the gutters in this country now are going to the size for the volume that we're getting in such a short period of time. Because all the small gutters are just... So those kind of details, it's going to be really hard for them to function.
It's a possibility, yes. But this particular one was in it was in the Gloucester. It was on a hill facing the west. I mean, it got really a lot of sort of driving rain on it. Yeah, other problems with this one. It leaked at the eaves, which ran down the windows onto the windowsill, and then off the windowsill onto the floor, as you can see there. It came through the side door because they put in a step which was too high, poured through there. There was another problem. This is a photograph taken before I went because you've got the dry lining on that corner. At that stage you couldn't open either of those two doors properly because the hinges, this part of the hinges hit the plasterboard. They'd removed it there and it was okay. The ridge leaked. You see we've got the ice cream cartons here to collect it, and you can see it's still coming in through those doors as well, around the edges at the bottom. It's a complete disaster, the whole thing really. I was puzzled by how the water was coming in at the eaves actually, so I devised this very simple test after I'd been to send it to the client and asked them to sort of basically do this, shoot a hose pipe up there and see where the water does come through. They carried out the test, sort of keeping it going for about 5 minutes in the same place, and reported that the water didn't appear anywhere. I can only assume that the Conservatory people had actually been back by that time and cured some of those leaks. Heat loss. Don't want to get too much involved in this one now because it's too complicated, but basically if the conservatory forms part of the house by taking out the doors, you would need to include it as part of the house and do all the sort of heat loss calculations, etc. If the conservatory is still properly divided off the house, then it doesn't apply. Document Part L, which, as the guy was talking about this morning, it's continually being upgraded and the requirements and that, and people now just basically go to an energy assessor to work out the necessary information on that running through the software, etc. If you need an energy assessor, go to the website there. I would recommend it.
If they take away the separation, then according to the other rules, it's no longer a conservatory, so all the
Like this-
buildings-
Like this one, yes. Yeah, as I said before, a lot of people, you see them do all these extensions and blah, 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 and have conservatories, and they'll even tell you, yes, okay, when the building inspector's been and checked all the other bits of work we've done, we're going to take this away from the conservatory and open it up to the house. And as I say, it gets picked up sometimes when you're trying to sell the house, they have to put the doors back.
So, can I just ask, what should happen is you're saying if they put a heating system into the conservatories with some power plants, the U values of what's there, which will obviously not be very good in terms of insulation, but the heating contractor has to design so that the output meets what the U value is. Is that simplest
You mean if you take the doors away and make it part of the house?
Yeah.
Or keep, yeah. Yeah, I mean, yeah, if you take that away, then that's part of the house. You've got to really consider the sort of heat loss and everything for the whole property.
I mean, you can't do it. Okay, so there's trade-off here, so you can't do it in isolation.
Yeah, if you've got the doors in, then it's a sort of separate little bit, and they prefer you don't have any fixed heating in there, but if you do have fixed heating, you need to have separate controls for it, basically. But you're right, the heat loss would be absolutely tremendous from some of these. I mean, that one's not too bad because it's at least got one solid wall, but some of the more open ones. I've got a job up in London at the moment in Battersea where it was described as a glass room. It's not actually part of the house because they have got this door in between, but it's used as a business for meditation and things. It is actually glass. There's no sort of framing hardly like this one. It's big sliding doors on that roof, fully glazed as well. And it's all single glazing as well. And she's complaining that it's cold. She has got these two little heaters going all the time, and it still doesn't get hot in winter, which is not at all surprising. But you know, she was basically made, I think, the big mistake of going to conservatory people and what looks like a very sort of high-spec German manufactured conservatory system. They put it up there, but she really wasn't advised well, and she should really have gone to an architect who's quite a specialist in creating what was effectively a sort of a business commercial use space. It was. That's all on conservatories. Just got one other little problem which I came across twice this last year. Never come across it before, but twice last year. This is a private house, a small estate, and fairly standard arrangements where you've got a garage attached to the side wall of the house. Where it's attached, there was all this repointing and cracking on both the front and the back. And also other properties on the development, similar ones, all had the same sort of cracking. When you got a bit closer, you could actually see there's a damp-proof course material going through here. But why has it sort of cracked particularly and moved a lot? But of course, in the garage itself and in the roof space covered by the garage roof, it's all concrete blocks, and concrete blocks shrink a lot. Usually we're used to them shrinking in the horizontal direction and getting vertical cracks, but equally they do go down as well. And another one there, that was in Basingstoke. These sort of corner blocks which went higher, there was 8 of those. So we've got sort of 16 of these roof abutments altogether, and every one of them have got similar cracking to that previous one, because it's all concrete block work on the inside there supporting the brickwork, or not supporting the brickwork actually, because brickwork is actually arching over it. That was on the back side where they put a stick-on type flashing just to protect it at the time. When all that was pulled back again, we discovered damp-proof course running through there, presumably cavity trays. And that's the last one. So, any questions?
What's the moral of the story? Don't get a conservatory.
Get an architect to design it.
That's a good idea.
Yes. Yes. Yeah.
Right, there's a lot of adverts at the moment for people who have glass or polycarbonate roof conservatories, getting them changed to tiles. So the loading aspect is really important because the concrete tiles weigh a lot more than the polycarbonate.
Yeah. Absolutely. And they're not translucent,
No,
so it's no longer a conservatory. Also, I think there are things for getting, are they real tile? You can get some other decorative panel, light panel coverings as well. But you know, once you take away that translucency, then it's no longer a conservatory.
The IBC have said that they, because of these, they're only interested in that particular part of the rest of the rooms.
Yes.
We just had our roof changed from, because when it was rebuilt, conservatory, the roof was slightly too big to go back on, because the builder made a bit of a mistake. So we put a lightweight roof on, and the planning actually said they were happy with that because it could be easily removed and replaced, therefore it's still classed as a conservatory.
But it wasn't translucent. You're lucky then.
Mm.
Yeah, yes. Yes, strictly speaking, it wasn't big. But it was probably small enough for exemption from building regs anyway, was it? No, it wouldn't be, no.
Big conservatory.
Yeah.
They actually made a rule, because I looked at all the same queries you
Yeah.
had, and the IBC actually said, well, we're going to class it as an improvement.
Yeah.
Anyway, it's not making them worse than it was. So we're again, as I say, we're only applying the rules to, as long as it's got support, adequate support for a
Yeah.
light roof.
Mm. Yeah. Actually, you shouldn't have it done by an architect. You should have it by an architect and a structural engineer. So.
Yeah, you're right, that's true.
And the party also,
Just a general point, it's quite surprising with these very, very long, fragile roofs, they put them in a tall building, no snow guards. So when the snow melts on the main roof, you get a horrible bang.
You could do, if you get snow. You don't get much snow these days. That's not I mean, some are quite good. When I was upgrading this, I came across a website for one of the manufacturers, and they've got lots of detailed tables for their rafters and the spans and the loads they could take and everything, you know, everything you needed to actually design it and make sure that it was okay. But the foundations are usually the main problem. Yeah.
Thank you very much.